All right, I have 12:01, so I'm going to get started with the introduction. Let me just find my slides here. You see my slides? Good? Yes, thumbs up. Okay, cool. So welcome, and just as a first point of housekeeping, this session will be recorded and made available afterwards on our YouTube channel, so fair warning about that. And with that, I'd like to welcome you to our April 2021 virtual quality talk. My name is Tina, and I am your KWSQA president. And we'd also like to thank D2L. They continue to let us use their corporate Zoom account for these meetings. So shout out to D2L for their support. If you're new to the KWSQA or don't already follow us on Twitter, we recommend that as one great way of keeping in touch with us. We do post all of the latest happenings on Twitter, whether it's about upcoming events or ways you can get involved. So check us out. We are at KWSQA. And these are the great people who work behind the scenes to bring you these KWSQA events. So thanks as always to the rest of the board members for their help and support with keeping our organization going. Speaking of upcoming events, we've got a few on the calendar. So next month we have Ali Hill joining us on May 26th. In June, we're still finalizing exactly who our speaker is going to be, but just wanted to give you a heads up about the date. So it's going to be June 23rd, which is the second last Wednesday of the month. Normally, you would be used to these quality talks being on the last Wednesday of the month, but the last Wednesday of June is June 30th, kind of right in the middle of a week that I'm guessing a lot of people might take some vacation time or have other plans related to the stat holiday that we have here in Canada. So we are moving the June quality talk to June 23rd. So take note of that. And then we've got a talk in July booked as well. We decided to keep going through the summer months. Normally we take a break during the summer from quality talks, but and sort of partly to give the board time to prepare for the upcoming conference in September. But as you all know, we are not doing targeting quality this year, and so we just decided to continue with our monthly cadence for quality talks every month this year. And speaking of quality talks later this year, we do still have some slots open sort of later on in the calendar. So if you've got an idea for a talk that you would be interested in sharing with this group, please do let us know. We have a CFP form that's always available from our website anytime. So feel free to head over there and tell us a little bit about yourself and your talk. We would love to hear from you. So virtual testing games, we are finally bringing testing games back. I think we had a testing games event with Shiny Docs scheduled for March 2020, which is over a year ago now, and we've finally gotten things ready and prepared and figured out how to do this hopefully effectively in a virtual format. And we have narrowed down the timing to a Tuesday evening in June. So pretty soon, since we're already at the end of April here. So if you're looking for something fun to do on a Tuesday evening, we will share more details soon about exactly which Tuesday it's going to be and how you can participate. But we are co-hosting this with Shiny Docs, the company that we were planning to work with last year. So we're very excited to, at long last, be offering this event. So stay tuned on that one. Another update for this month is that we also finally figured out our sustaining membership purchase process. Turned out to be somewhat more complicated than we were expecting, but anyway, sustaining memberships are available now via our website. As I've mentioned before, they cost $20, and the reason you might purchase one of these, even though all of our events right now, our online events, are free and don't require you to purchase a membership. Is you'd purchase one if you just want to help support our organization. Obviously, we don't have any income streams right now. And the other reason that you might purchase a membership is if you are living or working in Waterloo region and you want to be eligible to either vote in or run in our board of directors election later this year. So it is a requirement that you are a member of the KWSQA in order to vote or run. So that would be another good reason to purchase one of these memberships. And we hope we've made it super easy to do. You basically just go to our homepage, kwsqa.org, and click the Buy Now button there that you see on the screen that I've circled. But do let us know if you run into any issues with the payment process. It should be pretty quick and easy. All right, and so just a reminder that our code of conduct still applies in the same way at our virtual meetings as it used to in our in-person meetings. And as always, please feel free to reach out anytime if you have a question about the code of conduct. We are here to help and support you with that. All right, so let's get to the exciting part, which is the reason you're all here. You're all here because you want to hear today's presentation. And so the first 20 minutes or so of the presentation are pre-recorded. So we're trying something a little different here. So we're going to play a video that, as I said, is about 20 minutes in length to start. And the cool thing about having it pre-recorded is that while the video is playing, you can chat with our speaker who is in the call right now and ready and willing to take your questions via chat while the video portion is playing. Once the video ends, there'll be a little bit of additional content that Laveena is going to share live, not pre-recorded, and then we'll switch into more of the traditional open Q&A where you can come off mute and ask questions live or continue to ask in chat. That works too. But so that's sort of the overall flow. We'll do the video where you can chat and then additional content and more Q&A afterwards. And finally, after the meeting, you'll receive a survey in your email asking you for feedback on how the meeting went. And we'd love to hear from you both from just a logistics of the meeting perspective and also how you found the content of the presentation today. So with that, I would like to introduce you to Laveena, who is our presenter for today. She's joining us from London, England, so it's a little later in the day for her. But yeah, it's been really great to be able to bring in some speakers that are from a little farther away over the last several months, because obviously there's no travel required for a virtual event. And so it's been exciting for me to get to know people all around the world who are speaking on topics related to testing. And it's been really great to make the acquaintance of Laveena, and hopefully someday she can come to one of our in-person events, maybe targeting quality or something when our conference starts back up. But anyway, thank you, Laveena, for being here today and welcome. I guess we'll hear a bit more from you after the video finishes, but yeah, I think that's it for my slides and my intro. I'm going to stop sharing now, and we have Rob, one of our trustee board members, who is going to share the video.
Hi everyone, welcome to my talk on testing a data science model. I appreciate this is an emerging area, therefore I found it quite useful to actually share my knowledge with you. I've actually done some research and asked some colleagues around the world who are in testing if they've actually been involved in testing a model or a data science model. And most of them came back saying that they're aware of this, but they've not actually been working in these teams. So I thought that's a great opportunity for us to actually get into. And in this session, my aim would be to actually give you an overview of what this is and try and inspire and guide you to see if you might end up liking this area and you could actually go and explore. So without further ado, let's get started. First of all, a little about myself. I've graduated with a BSc Honours in Computer Science. I fell into testing, I had no idea what testing was, and today I've got more than 7 years of experience and I find it really, really interesting to learn and to share. I've worked within various industries, as you can see, and some of my hobbies include dancing, yoga, teaching, and baking. Today's session would include information about what is a data science model, some background, the process around testing it, and some useful tips and complexities that I've come across and how those could be useful for you. Some stats. Currently, 80% of UK business are looking to hire a data scientist or seek data consultancy. IBM anticipates that data science will account for 28% of all digital jobs by 2020. This is great. This is a great opportunity for us to actually go in and validate those models and understand what they are. So, what is data science? In a nutshell, it's a collection of tools and algorithms to understand hidden patterns from raw data. It allows decisions and predictions to be made, and the aim of making informed decisions, basically. So, data science is more of a forward looking approach. It works with real world scenarios. It's an exploratory way with the focus on analyzing the past or current data. And it uses predictive analytics. Some teams might be using this, so it's a buzzword for you, predictive analytics. Organizations can find and look into patterns contained within data in order to detect risks and opportunities. What is a model? So let me give you a quick analogy. Imagine you're commuting to work in the morning. You sit into your car, you put your seatbelt on, and you start. So that is your driving experience. So that's the data side of things. You need data for the model. Then your brain would try different driving patterns to learn what works best. So if you are faced with traffic, you would find the best route to get out of the traffic. So that's the computing side of thing. And the model side of thing is an equation of data inputs affecting your target value. In this case, how long it takes for you to get to work. So if you got to work sooner, your model worked great. But if you got to work a bit late, your model needs training. Let me give you another example. Example is for a manufacturing firm. You can check what they sold last week and then check what if they use the same assumptions that were used then, what would be an acceptable sale for next week. This is basically sales data of a client to improve their production. So data science modeling, what it does, it assesses the set of conditions and it guides you to make informed decision. Now, remember, a model is a statistical black box. It's full of funky algorithms. And it uses probability distribution to understand the behavior of its inputs. It's more of a what if model. So if a customer uses the parameter for the model suggested, then what their business could look like. It uses genetic algorithms as well. So genetic algorithms are algorithms that reflect the process of natural selection, where the fittest individuals are selected and inspired by Charles Darwin, actually. So yeah, a model produces some indications that are being used as guidelines for your clients, and each model would use configurations or parameters per the client requirements. So what we do as testers, we actually test towards the expected outcomes and see if they're actually in line with what we need to provide or they're actually not. So we need to raise those as concerns. So the benefits of data science model is to help craft better decision making, identifying opportunities for businesses that they were not aware of, actions based on trends to help define goals, data-driven evidence, identification and refining of target results, so you're training your model, and mimics real-life scenarios. A model needs data, and the data, as you can see, is in 4 different styles. So structured data is it adheres to predefined data models. It's easy to aggregate data from various locations and databases, easy to store, access, and process it, just like Excel files. Then you have unstructured data, which is not organized in a predefined manner. It's got irregularities in the data, therefore ambiguous as well. I use unstructured data, and it's important. What we have in our team is data schema, where the data engineer provides a data schema that we send to the clients, and we receive the data in terms of that data schema, which reduces any data biases. Then you have semi-structured data, which is self-describing data, uses tags and markers such as JSON and XML files. And lastly, you've got metadata, which, for example, could be photographs, and it provides additional information about a data set by telling you when it was taken and where it was taken. A basic kind of architecture here for you, and the scenario we will use is, imagine you are providing money on credit. then the probability of customers making future credit payments on time is a matter of concern to you. So what you would do is you would push in the raw data from the clients. You would obviously have features on top of it that are doing what the client requires. You have your learning algorithm, which is the predictive analytics side of things. So just a little recap of what this was. It's a use of statistical and machine learning techniques to identify the likelihood of future outcomes based on historical data. Organizations use this to sift through current and historical data to detect trends and forecast events and conditions that should occur at a specific time. And then comes your model side of things with genetic algorithms. Now, genetic algorithms cause a bit of stochasticness, which means randomness. This randomness does not essentially have to be wrong, but if you have acceptable deviation set in your team as a process, then these could still go ahead. And then it provides you some future-like data if you're using predictive analytics in your team. So here you can build a model which can perform predictive analytics on the payment history of a customer to predict if the future payments will be on time or not. Now, before we start testing, it's important to not have the elephant in the room. Make sure all of you have the requirements and you understand the requirements in the same manner. You're all on the same boat. So have requirements gathering sessions, have planning sessions to brainstorm possible solutions, design and prototyping sessions, go and implement the model and actually test it at every stage. Don't leave testing till the end. And what you could do is, if you're in an agile team, you can use the Three Amigos session to actually understand the problem the client is facing and how you can best provide a solution. Is the solution good enough for the client? Is it testable? Is it not testable? These are the kind of questions and ambiguities you can ask in these sessions. So let's get started. So a model can be of two types. It could be off the shelf or custom made. In my team, we've got a custom made model. Depending on what you use, you need to understand that you should have processes around testing for it. Also, you should consider how often you're going to train your model. So what I mean by training is you input data, you run it, and you observe the results and see if they're good or not. Also, as I've mentioned earlier, because of the use of genetic algorithms in the model, it would provide a bit of stochasticness, a randomness. So let me give you a small little analogy again. 5 plus 3 for me and you is 8. But for the model, 5 will go in as it is, and it will output as it is. 3 will go as it is and output as it is, but the result 8 would be 8.00001 or 8.00065. This, when you see it, you might think it's wrong, but it's if you've got thresholds in your team, so say for example you accept deviations between 3 and 5% of your actual results, then this is not essentially a wrong result. It's within your cap of threshold. So you can still go and accept it. So that's the type of stochasticness you might face for some type of data set that's running through the model. Some testing then. So verify the data set that you use for the model, have some understanding of what this data set is and what are we trying to provide. Validate the input versus output data results, understand the shape of your result, and make sure the values are of the right type and the data columns are matching where they should match, and stochastic where they should be random. Test the areas you're certain about and uncertain about, so happy path and unhappy path testing, and those which cause some uncertainty in terms of results or due to the randomness. Make sure the results are within threshold, and make sure you get the thumbs up from the data scientists as well to understand that this is an acceptable result we can pass forward. Make sure the data pipeline works as expected, so no data is dropped or duplicates provided. And test using different parameters or configurations per your clients. So if you might have certain things that only accept strings, try and put some integers and see how it behaves. And lastly, explore the model, understand the model. Just go in without any agenda. Try and see if you find any underlying bug that you never knew about. So these are quite important things. Some more things that I've come across when testing data science models is new feature testing and regression testing. So when a new feature comes in, there's nothing to compare the model run to. Since it's a new implementation, you may find more issues around it. So try applying different configuration parameters and edge cases to understand the model outputs. If you do end up finding bugs as well, make sure they're not repeatable. Make sure they're solved once and for all. Work on a test plan with a data scientist and understand what is actually being implemented. Consult your results with a data scientist for more conciseness. The logic is tested in the unit tests. Run a model prior to a new feature and after. This is what I tend to do. So what you would see is something before would have less optimized results, and after you might have better results. Maybe the model took less time for a certain thing in your new implementation, and it gave you better results. And of course, exploratory testing. In terms of regression testing, what is regression testing? So you can confirm that a recent program or code change has not adversely affected existing features, and make sure bugs that were opened in the new feature are completely resolved. So what I tend to do here is I have a baseline run that I would potentially run in the previous release, and then I would create a new run and make sure they align. And if they are slightly bit different, that's okay, within the threshold of 3 to 5%. But if they're way too different, then you need to make sure you mention this to your team, and you can actually deep dive further with the data scientists and see what actually went wrong and if we can actually release or not. Remember, some models can have degree of randomness, so some areas would be expected to be random. Don't worry, deviation doesn't mean negative at all. If you have thresholds, it can still go ahead if accepted. No equation for the best answer exists, and rely on a good enough and fast enough answer. I know some of you may be thinking around automation. In this area, there's two things. If you do need human intervention, then I would not suggest automating this. But if you do have thresholds set, then you could potentially do some automation around that. So if the results are different to the prior release results, so if you have the threshold set, it would still potentially go ahead and you can automate that. But in terms of, for me and my team, my UI, I have a UI to run the model, so we can automate the front end side of things and run the model from the front end. So that's doable. Some useful questions and curiosities I had, so I thought might be useful to share with you. What is an acceptable test? Has a run completed and nothing broke within various stages of a model? Have we found anomalies? Did we drop some data? How do we know what we produced is the right result? How accurate are my results? What is an acceptable deviation? So all of these can be answered when you ask within your team. Therefore, be vocal. And other than that, what I would say is, how do I know I've produced the right results? So if you have a baseline run and you compare to it and you are kind of aligned, then that's good confidence. You've got great confidence there to actually go and provide those results forward, or you can be confident with those results. And in terms of deviation, if you've got thresholds in place and you've actually mentioned this to the data scientist that it's between a threshold, is it okay for me to pass this testing or not, then that's another thing. So stay in good communication with your data scientist and get the thumbs up from them as well. Let's practice this. So these are some locations and some birds in these locations. So what you need to understand is we are going to input this into the model and then see it in a dashboard if that's what you're using. So we're going to basically input the locations, which will be exactly same in the output, but the number of birds in each location may change. So this is just a visual example. I'm not going to do any technical check here. So the questions you should ask here is, how many birds were counted on the 7th site, for example, 7th site? What is the total number of birds counted across all sites? What is the average number of birds seen on a site? These are the kind of questions you would come up. And then, would I expect an increase in site A1 or would I expect a decrease? This is now predicting things. So that's useful. And then at the end of it, when you finish your testing and running the model, you should understand, have I got a good understanding of what the model has provided? Have the predictive analytics and the genetic algorithms worked as expected? Does the shape of my data look good? What I mean by shape is not triangle, square, or circle. What I mean is a histogram or graph. Does it look good? Have I got any outliers? And if so, are those outliers acceptable or not? What I tend to use is the mean, the standard deviation, the absolute difference, the percentage difference to help me validate my results. Some complexities I've come across are around data. So if you've got less clients, the best option would be to have synthetic data set or a golden data set for some of you, as you may know it, and mimic your client data, but respect the policies of the client data. Now, if we anonymize, make sure the file size is matched to the client's file size as well. So if you are anonymizing 50 characters, make sure you anonymize the 50 characters. What I did was I anonymized 50 characters down to 10. So some product description that was 50 characters, I wrote it down as description 1, 2, and 3. So that changes your file size. So try and stick to the exact file size your client has, because then you are reducing another potential bug of what the files or the data size that can be accepted into your model. Also, the model is quite complex. I don't expect you to know everything about the model, but have good understanding. That's vital. Knowledge silos. So some people may know a lot, some might not. So it's okay. Just try and be vocal. Make sure your questions are answered and make sure you document things as well. Dependencies. So there might be something that you might be building in the back end, but it may not have been mentioned to the front end developer. So make sure this is mentioned and you're not blocked. Your testing should be smooth end to end. So just make sure dependencies are captured, and this happens usually in the requirement side of things and the 3Amigo session. Some tips for you to take away. So make sure you understand the data from a business point of view. Don't derail. I know that your model mimics real life scenarios and there's tons of assumptions. Assumptions limit scope, basically. You cannot pick all assumptions realistically, because then you are derailing and what needs to be delivered won't be on time. So make sure you stick to your consumer requirements. Also, review and analyze a lot. So your specifications, you define your test scenarios, execute test scripts, review them, report and document if vital. I've been asked before if data science model testing can be done in agile, so in sprints. I've got 2 weekly sprints and it's possible, so definitely it can be done in sprints. Also, be ready for discrepancies. Just because a discrepancy sounds negative, it doesn't essentially mean negative. If you've got thresholds in place, that's all good. Some teams might need more precise results, so just reduce your threshold. Don't make it 3 to 5, make it less, 1 to 2, or just up to 1% discrepancy, deviation. Also, by providing these statistics and facts for employees and clients that they can access at any time, you are creating a smart and savvy team that can use these insights to drive more business. And once you have a process in your team, stick to it and try and look of ways to optimize it. We are not just optimizing the model here, we are optimizing the team as well in a way. Also, be present in all vital meetings. It's okay not to know everything. Pairing is useful. Raise your concerns wherever you find something that you don't understand. Make sure new features are being released often and bugs are not repeatable. And what does this leave me with? A hybrid tester, because I came in with testing knowledge and I've gained data science model validation knowledge. So we are hybrid testers here now. Okay, lastly, some useful tools for you to take away is SQL if you're using databases, some statistical knowledge. You don't have to be a pro. You can do most of it on Excel, by the way, the statistics, the basic ones. If you're using a front end to drive your model, then developer tools would be good to check your endpoints. And Miro dashboard if you're doing any 3Amigo session. So, a little summary. Basically, aim to do some edge case testing and exploratory testing in your model. Make sure the model is providing accurate and precise results. And if you have thresholds, any deviation is within the threshold. Make sure the model can perform at a scale with new features. So make sure the model is maintainable as well, because if new features are coming in and your model is slowing down, there's something that's not happening right. Make sure it's still behaving as it is and it's not taking too long and no new implementation is impacting it negatively. So that was all from me. Thank you very much for attending my session. Please feel free to connect with me. I'd be happy to help you and share some more knowledge and learn from you.
All right, so we have made it through the pre-recorded part of this session. Looks like there's been a little bit of conversation in the chat. I don't know if maybe we want to bring that one to like a live chat so we can fully address the question. It looks like maybe getting into some details there might be useful. But otherwise, we also, Laveena, I think you wanted to share some additional content.
Yeah, I was just answering Neil's questions, quite useful question. Please do have a read on that. But what I wanted to share with you is many testers have asked me how to get involved in this area, because as I mentioned that in my presentation, not many testers are involved in this area and are quite keen. So it's just about us being a bit more open to opportunities, finding out if there's any data science, machine learning projects happening within our company, and trying to connect with the right people. That's what I would definitely suggest to do. And if not, just self-learn. So potentially do some Udemy courses, or just if you have a friend who's a data scientist, learn from them, see how they analyze, or even a data engineer, and then see if in the future you can share these kind of interests with your people lead or the person who you share your objectives with. You can probably mention to them that this is an area that I'm quite keen to being involved in, and if there's any future project coming up that could have this kind of potential, then please line me up for it. And yeah, I think we need more testers here, because when I joined my team, they had no testers, which worried me a little bit. That how were you delivering? Like, you need a tester. So they didn't understand that kind of area. So I had to introduce a lot of things to them. So I had to go from the very basics. I had to show them what a test plan is, a strategy. I know it's a bit traditional, but we had to start them from somewhere. So I just had a blank canvas and I said, right, I'm going to paint it the way I want, and just introduced them to what a tester does. A tester does not always find bugs in the developer's code. We are here to basically look forward to having better quality in the product, work together as a team, and provide the best quality we can as a team. So then I did try introducing all of those areas to them, things like accessibility, they didn't understand. So I had to present that as well, because if it's a front-end facing product, first thing, light bulb moment, right? Someone's going to use it. We need to make sure we are socially aware and we are accessible enough. So then everyone found that really useful. And sometimes it's about, some people might learn how to test, but might not have the testing mindset. So that's the kind of thing that I was trying to put in my team. And that's what I just wanted to share now as well with you. So feel free to be part of these kind of teams. They definitely need testers. That's what I'm trying to say. And it's fun. It's a different area, because I've come from like traditional style testing, waterfall style, to a very agile based team and a data sciencey team. So I've learned a lot, and a lot of useful information, how to analyze results. How do I know that this is the right result? How can I be 100% sure about it? So data scientists have really worked with me. We've paired together, we've pair tested, we've collaborated, and it's been an exceptional experience. And that's why I'm out here sharing this talk with you, that we need more testers involved here. And yeah, I thought it would be useful. And yeah, feel free to ask any more questions if you have.
So I think those are some great tips on, looking maybe for where there could be interesting data science things going on in your company and finding ways to get involved. What if you don't find anything? Are you aware of any sort of more open source or like public projects that are going on where maybe people could get a start instead?
There's actually loads of case studies that I'm aware of. I'm not aware of open projects. What I've done actually with one of my friends actually in the US. So what we did is we pair tested together. We found a data set. We found a Jupyter notebook, and then we just had to kind of get a front end to be able to process all of that and understand results out of it. So it was really good to kind of pair test and learn new things in a different area, because I've worked for supply chains, at Deloitte, and you can all of you can actually go and search the product. It's called Supply Cycle, and if you type that on Google and just put Deloitte, you'll see what product it is. So I've worked for like a end-to-end product for companies, and it was very difficult to kind of share internal information with someone out there. So what we did was we found something online that we could both work together with and learn from each other. So that's something you can do. Apart from that, if there is a project in your company and right now it's not the right time for you to move there, maybe you can just have a coffee catch up with a tester from there, or even a developer, a data scientist, to understand what are they trying to do, and then potentially have those conversations going on, so that if ever you wanted to be part of that team, they know you because you've already had those chats. You've basically put a seed in there and then let it grow when it's the right time. So yeah, I think that's what I would suggest. And I do like a book, actually. It's from Iran Kinsbrunner, Accelerating Software Quality. There's loads of material inside there from loads of testers around AI, machine learning. So maybe just getting used to that to see if you like it or not. I fell into this team, so I had no idea of data science. So it was a matter of learning on the job. And thankfully, to the kind data scientists and data engineers, we actually kind of gelled together. So I could understand, and everyone was really helpful. So that was really good as well, because there are sometimes situations where testers ask loads of questions and you don't get the answers, but I was the one being very annoying. Like, I've got too many questions, and I wouldn't keep quiet. I'd ask them, even if I'd look a bit silly sometimes, but it's just for me to learn. And if there is someone in the team, right, who is a little bit introvert, I might be answering questions for them through being vocal. So ask a lot of questions as well. I definitely would suggest that.
Being annoying is good sometimes.
Yeah, because I would Slack message them all the time, right? Why are we doing this kind of analysis? Why is the model running this way with the parameter? Why can't I do this? Why do I do this? And they would be like, Laveena, because it's like that, like that, like that. And then I'd be like, thank you very much.
Laveena, could I get you to just put a link to that book you mentioned in the chat?
Yes, sure, I'll do that. Just shall I just do it right now?
Whenever is handy for you.
Yeah, because I think Zoom loses
Yeah.
the chat. So Aaron Kinsberg, I'll just quickly put it here. There it is. It's the first one over here. There you go. I've put the Amazon link to it.
Oh, Amazon links.
Yeah, I found that quite useful because it's different stories to relate with. Maybe I can relate with one story and then just few snippets of other stories, and then I can kind of share my knowledge through that. But yeah, also I wanted to suggest that obviously everyone doesn't have a data science background. I didn't have one, but it wasn't, well, I can say that I do not know 100% of data science, but I can test models. This is what I've learned. I've learned how to validate results. I've learned how to gain enough confidence in those results, make sure my analysis is accurate, and understand that I'm doing the right thing, basically. So again, that's basically having a tester's mindset is what I brought with me, my testing suitcase, and added a bit of data science onto it to bring more knowledge. So I would definitely suggest, as I said earlier, Udemy courses were helpful, but more than that, just asking loads of questions and pairing up with data scientists just to see what they do and how they do it.
Great tips. I wonder if we can get back to the earlier question that was raised in the chat while the video was playing about the drift of the baseline. I think I understand what that question was getting at, and I'm not sure if we got to all aspects of it. Like in the example that you gave at one point in the video, like where 5 plus 3 should equal 8, but maybe it's really 8.0001 or 00065. So what if, I think this is the scenario that we're talking about is, so what if like one time you do a run and the model outputs 8.0005 and that's within your acceptable threshold. And so you say like, yes, okay, this is a good new baseline. And then the next time its result is 8.002, like, I don't know, something larger than the previous result, right? Yeah. And you're just sort of like drifting in one direction all the time. And then if over, say, like 10 or 20 runs, now you've shifted your baseline always in the same direction. And actually you're getting the result that 5 + 3 = 9, but you just sort of slowly inched your way there. And now you're still saying that this is acceptable. Like, is that a possible scenario, first of all? And second of all, Neil, if that's not the right kind of scenario you were thinking of, you can feel free to correct me, but.
Yeah, so these kind of situations are actually possible because our model is made in-house. So we have not used any existing models. We have used business logics that exist, but some of the logics are actually coded in-house. So there have been situations where we have a baseline and my run, for example, has resulted in different results. I wasn't expecting those results. So I just stopped there. I would not go ahead with them. I wouldn't let this become the next baseline because they are not within our threshold. And previously, this was all done manually. So I would literally go on Excel sheets and actually check those particular columns which are stochastic or become random, have not been too deviated from the last baseline. And many times I did see massive deviations. So what I would do at that point is I would have a discussion with the data scientist. I would explain what I've done and how I've done it. I would show them the whole collection of parameters I've used, because the parameters are the main brain that runs the model. And sometimes what would happen is maybe my parameter setting was not accurate. So they would tell me to just rerun the model and see what happens. And then when I rerun the model, my result would look a bit more similar to the last baseline. And that's when we would kind of compare it manually or now with automation checks. And then continue, we'll give it a pass. But if it's above threshold, we won't give it a pass. Either that's a problem in the model or parameters are not acting as they should. What I mean by parameters is before I press play button for the model to run, I have to enter certain parameters. Some of them will be an exact match at the output. Some of them are going to change. So there were at least 2 or 3 columns that would change at various different stages. So my eyes would always be onto them as to, right, what has actually changed, and if this is going to cause a problem or it's going to stop me from making this my next baseline. But we would never let anything that's above our threshold go past. So we either stop the release or we either delay our release, but we won't let a baseline that's not similar to last time go ahead. We were really strict.
Makes sense for like an individual run, but like just what is it possible that over time what you consider acceptable can change? Like maybe after 5 runs, you know, if you look back at what your value used to be, something that passes now would not have passed 5 runs ago. Yeah, maybe that's okay. I don't know as much about this as you do, obviously.
Yeah, so it could be okay, but that's around us setting that strategy, because obviously our product grows, right? Every sprint we have something new added to the product, whether it's the model side of things, UI side of things. So our product is constantly growing and improving itself. So then what we had, say, last year, it could be still applied, but if our model requires different things or a different, different kind of parameters or values, then we can definitely improve our strategy and then sit down with a data scientist and be like, right, last year we were accepting these kind of results. Now that this has changed, what's the new process we could add? How do I know now my runs are good and I'm confident enough to release it? So then that's where we would sit down together and create a new strategy, maybe increase the threshold, decrease the threshold, but we will definitely keep the threshold idea there to gain more confidence around our results.
Okay. Yeah, that makes sense. Just making sure to check back at other points in time, like this is what we used to consider a pass and this is what's passing today, and just having that discussion. That makes sense.
And again, your clients are going to have different requirements. They're not going to stick to the requirements 2 years ago to now. So things will change. Every client for us means a different model. But by a model, I mean same brain, but different parameters. So we had over 4 clients. So everyone had different parameters. And now we have parameters to run futuristic-like data. We have parameters to run historic-like data. So then I would pick up the historic, my other colleague would pick up the future-like, and then we would basically do our comparisons and then reconvene and decide, right, was everything good in your run? Are we good to release, or something looks funny and we delay the release, or we just have a quick discussion with our data scientists to understand we are good to go or not? So I hope I've answered that question.
I think so, yeah. There might be something new in the chat. Mark has a question that maybe you could take a look at.
We wouldn't reset our runs. We would basically, for each kind of release, we would run a new, fresh model. We wouldn't kind of reset what we had previously, Mark. What we would do is we would use the same set of parameters to kick off that model for that client that I would be running for. And then I would do the comparison once the model is finished producing my results. But adjusting things to get the right results, we wouldn't do that. We'd use exactly the same parameters. Yeah, I hope I've answered your question, Mark. Please give me a thumbs up or something so I know. Yeah, all right, great. Then I've got Rohan. How many runs do you usually do average the results out of a single release? So I would just do one run. I would do one run and compare it to my baseline run. I wouldn't do more than one run unless I've found an issue with my analysis or with my parameters. Then I do another rerun. But I will always compare my new run to my last baseline. That's how we would do. So as Neil said, we are rebaselining basically. But we make sure that we are within the threshold. We are not changing throughout time massively. Neil says, one of your slides, I believe you stated that logic was tested in unit test. Would the logic not extend over multiple units unless you are defining units differently from what I'm used to? So what I meant by that is we let the developers and the data scientists create their own unit tests in Python, because they are actually building the model themselves. So they would do their unit testing themselves. As testers, we wouldn't be part of that unit test, but we would definitely ask them for any new feature that they're doing if they have a unit test and if they can walk me through it. But I wouldn't be part of that. I'd be part more around the middle part of the testing pyramid and the top part, so the system integration and then the UI side of things. That's where my my major area was. I hope I've answered your question, Neil.
Any other? Oh, there's something.
I've got Janine's question. Did any system that you worked on have some sort of continuous learning cycle integrated in it? What do you mean by learning cycle? Do you mean by I learned something every time we released, or some sort of diagram that helped me understand things throughout time?
Well, I'm just wondering, I hope you can hear me.
I can't.
I was just wondering whether any of like feeding data into it continuously and changing the model, I guess, like rerunning the learning elements, or did the system learn and then create a static model and then that was what was published? Or
Yeah, so basically our parameters is what makes our model learn what we want. So we would just run that pattern. It was repetitive, but that's what our model understood. So we would give it parameters that run it for specific parameters. And there was not only one or two parameters, there were loads of parameters. And we would run one stage, which was called segmentation. So that's getting all our data segmented. And then we would, once that segmentation completed, we would run the next part. So you can definitely look into this link, which I really want to share with you. So you can get a better understanding of what I actually did. It's got a video as well. So I think that would be quite useful for all of you. It's actually stating one of our clients as well. So you can have a look at all the stages we used to go. So the model was broken into two parts. So we would have a segmentation stage where we would run particular parameters to run the data segmentation. Then once that passes, we'll run the next stage. And then that's when we finally get all our files together, put it into the automation test, make sure we can compare them from the last baseline to this baseline, this one, and then see how different they are to determine if we are happy with this one or not.
thanks.
No worries.
Anyone else have a question or topic that they might like to raise before we finish off? If not, oh, there we go. We're still going.
Jeremy, have you run across any interesting scenarios, anecdotes from security perspective, image processing, where an image can have few pixels modified to signal the model to do something drastic or unintended, right? Security side of things, we have a third party who would do our pen testing. We were not doing security side of things because we were not that stable yet. We were just focusing on the model side of things and making sure that the model can provide the results to our clients because they're actually using it on a day-to-day basis right now. So our area to focus mainly was there. We do have pen testers who come and check security related areas. So that was their department, but I've personally not been involved there. However, I am doing the Ministry of Testing security training for the 30-day training, where every day you learn something new around security. So in my new team, which is more machine learning based, I'm going to try and bring that in slowly. But in this current, in the previous team, the data science team, we did not really have any security related, testing from my side. However, interesting scenarios, yes. So I once randomly went in and I said, I've got some time today. I'm not going to do ad hoc testing, but I'm going to do some exploratory testing. So I went in without any agenda. I didn't write anything down what I wanted to test. I just thought, let me play with the product and let's see what I find. And I found an underlying bug, which we never found because we were so strict on just testing our features and just making sure we give it a pass and we move the ticket to done so we can release this in the next release. Now, when I went with a clear mindset of not testing a feature, but just randomly checking what's going on, what is the model doing for me, we found an error that could have sabotaged the clients. Now, we were about to release 3 days after that. And because this prompted earlier, I stopped the release going ahead. We had to basically fix this error before we even release it. And even still till date, the product owner just thanks me all the time because it could have been massive chaos for the clients because we would be providing them the wrong results. And that makes the product look really poor quality wise. So that was one of the things that had happened. Apart from that, can't think of anything, but that was one major bug we had to basically stop going towards a release for. Other things, Yes, another that this is actually close enough to security actually. So we had some login issues. I would basically log in with my username and my password for the firm to allow access on the product. But when I sign out, it would not ask me to sign back in. If I go to the product again, I'm automatically signed in, which was a bit flaky, and I got a bit worried there. So this was something that me and another tester both found, and we were testing cookies on our page. We were just understanding how cookies are working. And I logged out and I thought, right, now I will have to log back in with my username and password. But it remembered me without me actually ticking on the box that remember me for next time. So that was something that was really bad on our end. So yeah, that was another kind of, I would say, security issue that we faced. But yeah, I hope that was okay, Jeremy.
Oh, thanks. No, those were interesting. Some interesting stories. Yeah. I'd heard that there was some security research into attacking AI, various forms of AI, and I just don't know the subject space at all. But
Yeah.
it is more like attacking the learning and the models themselves.
Yeah, we didn't face anything along that side. We didn't see any attack to our model.
It's actually kind of terrifying to think that, like, a security attack could be mounted on like the actual learning algorithm. And yeah, anyway, I'm sure there's lots of very interesting things to consider in these projects that maybe are outside of the space of what we're used to thinking about. So as you said earlier, definitely an interesting area for testers to get involved in, probably a lot of opportunity for developing strategies and approaches for these things that might look a little different than they normally do. All right, well, I guess we're just about out of time. So unless anyone has a really quick last minute question they want to throw in there, maybe we will end the session here. Really appreciate you coming and sharing your experience and knowledge, Laveena. It was great to meet you and hear from your experience in testing these kinds of projects. And yeah, we'd love to see you again someday in person at one of our conferences.
Thank you very, very much, everyone. And I hope I answered your questions as you expected. And I really hope to see you all in person for sure. Thank you very much. Have a lovely day.
If you think of anything else too, she had offered that you can connect on LinkedIn and Twitter as well. But
100%. I'm even happy to have coffee catch-ups or anything if you want to gain more knowledge or
Great.
learn from you as well.
All right, and thanks to all of you for participating in the Q&A portion too. We will see you next time.
Bye.